I did. So we'll take a break as soon as the pizza gets here.
Where'd you order it from?
Papa John.
I don't know if I paid.
Papa John.
I think that's my favorite. I don't know.
Are you going
It's a
tonight?
good pizza.
And like, like, I've wanted it. I don't know.
Okay, let's do this. Number one. Thank you, everyone, for showing up. Awesome. Good work. Let's see. The assignment of probability must obey which of the two following. Which of the, oh, sorry. Must obey which of the following. So does the probability need to be a number between 0 and 1? Yes, number 1, A. So true. Probability must be between 0 and 1. It actually can be 0, it actually can be 1, but as long as you're not greater than 1, as long as you're not negative, it's good. Letter B, the sum of all probabilities of outcomes in a sample space must be exactly 1. This is kind of true. Okay. This is true only if the events are disjoint. Or do we have events here? Outcomes. Outcomes. Only if the outcomes are disjoint.
Does that mean independent?
No. Very good. Very common confusion is like independence and disjoint are different concepts altogether.
Okay.
And actually, if two events are disjoint, they are automatically not independent. Okay.
If they're disjoint, they're not independent.
Yeah, we'll get to that in 1 second, and then I'll talk about that in 1 second. All right, letter C. The probability of all events is the sum of the outcomes in the sample space which make up the event. That is true. But again, outcomes must be disjoint. Letter D.
Aren't they saying the same things? Oh no.
All the probability of an event is the sum of all the outcomes in a sample space which say, wait, D is all of the above. E is A and B. So actually all of the above are true.
But the answer was C. I'm not C. E. It was A and B. It was
A and B only?
E. The answer was E.
Okay, so that's the whole thing with the outcomes must be disjoint.
Wait, can you explain something that's not disjoint?
Hmm?
Can you explain like an event that's not disjoint?
Outcomes that are not disjoint? For example, red cards and a deck of cards and kings.
What's disjoint?
What?
Those two sets, those two events are not disjoint because there is an outcome that is red and a king. Okay. So if I said a red card and a black card, those are disjoint. Okay?
And not disjoint, can you repeat again? So that's a red card and the deck of cards?
A red card, well, no, we have to talk about two outcomes as being disjoint or not disjoint.
So they're in this different sample spaces?
Yeah.
So
Not-
red cards and the hearts or something?
Red cards
that
and
would be-
heart cards are not
not
disjoint,
disjoint.
right? For them to be disjoint, they have to share no outcomes. So disjoint means no shared outcomes. Okay. And we're talking about disjoint. If two events are disjoint, then they are not independent. Okay? Because if you think about it, independent means that the probability, if you know the first one happened, the second one has the same probability of occurring. So, for example, red cards and black cards. If I know I got a red card, then the probability that I got a black card is automatically 0. So that changed the probabilities. So things that are disjoint are not independent.
Wait, so is the answer D or E?
I think because C required,
Don't they both require three?
they both kind of require. So A looks better now, right?
Should we just disregard this question?
Yeah. Well, I don't know.
The answer is E.
The answer said E, A, and B only. I have a problem with the answer.
So
Comments.
like on a test. you
I have a
say-
problem with the answer
Problem period.
since B is only true if the outcomes are disjoint. What was the answer? E?
Don't D and C.
Okay. So there are problems here.
So let's see.
There are problems.
You know, it's this question until you know the answers. You know, like the actual facts and probabilities that you do all the time. Thank you, Sharon.
Question 2. Event A occurs with a probability of 0.2. Event B occurs with a probability of 0.8. A and B are disjoint, mutually exclusive. Okay, so let's make that chart. Okay, here's our probability chart. We start off with A and A complement. Oops. A and A complement, and of course total. Then we have B and B complement.
How do you know when you make a chart in the square?
You can always make the chart in this. The square, I mean, I'm making the square.
Oh, it's the same thing.
Yeah.
Oh, okay.
Okay. So the probability that A occurs is 0.2. Is that right? 0.2? So I'll put a 0.2 down here. The probability that B occurs is 0.8. They are disjoint, so the probability that goes here is 0.
Because they never. Okay.
Okay.
Oh.
Okay. So if they're disjoint, that gives me a 0. That means this one has to be 0.8. This one has to be 0.2. All the cells need to add up to 1, right? So 0.8 times plus 0.2 is 1 already, so that needs to be 0. And this is 0.2. Everything adds up to 1. Okay? So not only are they disjoint, they are also complementary. Okay, so let's see. The probability of A and B being 0.16, that's going to be false. Okay, from the chart, right? B. Probability of A or B equals 1. That's true, right?
How do we know this?
Okay. Probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Probability of A was 0.2. Probability of B is 0.8. Probability of A and B is 0. That adds up to 1. Okay. C, probability of A and B equals 1. Again, false from the chart. D, probability of A or B is equal to 0.16. False, right? And that's false because we calculated it as 1 in letter B. And finally, E, both A and B are true. Nope. So the only one that's true is letter B. Make sense? Chart saving your life again? I think so. I like the chart. I like the probability chart a lot.
Is
Of-
that why you like this chapter so much?
I like this chapter so much because I feel like I'm actually doing math. And I don't have to read a lot.
Yeah, I hate reading.
No, I meant reading your answers.
Oh.
Yeah.
It's less makeup.
Yeah,
Stuff.
it's less of me to read your stuff.
Just look at numbers.
3. A fair coin is tossed 4 times. Each time the coin lands head up. What's the probability, or if a coin is tossed 1,996 more times, how many heads are we likely to get in those 1,996 tosses?
You do 1/2 times 9,000.
Yeah. Half of those should be predicted to be 1996. No matter what happened in the previous 4, you know, the coin doesn't have a memory of what happened to those in those previous 4. It's, yeah, every toss is 50-50. So 0.5 times 1996. Yeah, we expect 998 more heads.
Or tails, right?
Is it tails?
Could it also be tails?
It could. Either way, yeah. But is the question heads or tails? Okay, good. Yeah, we also expect 998 tails, but that's not really the question. Okay? Remember, the coin has no memory.
I'm a little confused. Where'd you get the 0.5 from?
There are 2 outcomes. They are equally likely.
Okay.
It's just flipping a coin. A fair coin.
Question 4. Die is loaded so that the number 6 comes up 3 times as often as the other numbers. Okay. So we're talking about a 6-sided die, right? But if you want to look at it, each one of our outcomes are equally likely, right? Except for 6. So it's kind of like looking like this. We have 8 outcomes. 1, 2, 3, 4, 5, 6, 6, and 6. There are actually 8 outcomes. The 6 is 3 times more likely than the other outcomes. So that's kind of like looking at an 8-sided die, where 3 of the sides say 6. So the probability of 1 or 6, that's going to be equal to the number of positive outcomes divided by the total number of outcomes. Well, how many outcomes are positive to our experiment? 1, 2, 3, 4. Total number of outcomes? 8. Probability of 1 over 6 is 0.5.
What do you mean by like, I don't get what you mean by positive outcome. Like what we want?
Yeah. How many of these outcomes would satisfy 1 or 6? Or in this case, how many of the outcomes that we listed here are a 1 or a 6? Good? 5. Oh, we gotta read this. Getting worried about this pizza. It should be here by now.
You want me to go get it like last time?
Yeah. Oh, I already paid tip.
Okay.
You don't have to give him nothing.
Just get the pizza.
Get the pizza.
And run.
I mean, if you want to give him extra money, that's fine.
No, it's not here.
Okay. In a particular game, a fair die is tossed. The number of spots showing is either a 4 or 5. You win $1. If the spots showing is a 6, you win $4. The number of spots showing is a 1, 2, or 3, you win nothing. You're playing the game twice.
So the outcomes are twice different?
Okay. So what's the probability that you win $4? Oh, Hello, hello.
That's why I bet I
Yes, I'm gonna send some people out there to pick up the pizza. Yes, just the main double doors. They always sound like they know what they're doing, even though they've probably delivered here like 100 times.
Yeah. Because they don't know
Well, it's
where.
not the same person.
Oh look, Snack Times reblogged my post on Tumblr.
I have a Tumblr. You have everything that's over here.
Actually,
Mr. Freya, follow
Yeah.
me on Twitter.
Let's go, Brandon.
because I know what it's like. I know what it's like.
Of course, I have a Tumblr.
Mr. Freya, you are with the
I
kids.
just want to make sure that you're delivering it to the right place.
See,
Oh, do you have a MySpace, Mr. Freya?
I do have MySpace.
Ooh, follow me on MySpace.
They reblogged this one.
Ooh, sushi. Did you make it?
No,
Oh.
Neil Bookface.
jalapeno Toro roll.
Where's it from?
Teru sushi.
I really want to try to.
It's so good. Oh, we need to finish this up. Sorry. 5.
Is it point?
The probability that we win 6 4 times, okay? So the probability of winning $4 is 1 outcome out of 6, right? The probability of winning $1, how many outcomes is that? 2 outcomes?
Is this number?
2 outcomes out of
Number
6,
six?
right? This is your number 5.
Oh,
And the probability of winning nothing?
3 out of 6.
Yeah, 3 out of 6.
6 is weird.
Okay, so if I do this, if I roll the die, are the die rolls independent?
Yeah.
Yes, you can always count on that. Die rolls are independent. So the probability of winning $4 and then $4,
1 over.
1 over 6 times 1 over 6.
yeah, it's 1/6 times 1/6. 0.0278.
And is it like that?
Yeah, like an N. And.
Oh.
Because the and has a letter N in it.
Oh, I was thinking the A.
So N is the N, and then it's or the U.
Yeah.
Wait, she said it started
What
with
about
an
the-
A?
Yeah, like A.
Because if I roll a 3, is that going to change the probability that I roll a 3 again? Independent.
The die doesn't know what happened.
It has no memory.
The die has no memory. They're not magic.
Cards.
Okay, so tell me if it were.
The 911 call.
If they were to wait, hold on. What's your question?
I'm confused, like the difference. Okay, I don't know.
You want an example for Thunder?
The comment is like, okay.
Justin?
Let's say there's this pizza.
You know how N is and? So with U, the or.
Yeah. 6. The probability that we win at least $1, right? Probability of winning at least $1. Like I've tried to say in a bunch of different times, this is 1 minus the probability of winning nothing. Okay? So we can calculate that. What's the probability of winning $0?
3 over
6.
6.
1/2.
Twice.
So it's 0.5.
Wait, yeah.
Probability of winning $0 twice is equal to 1/2 times 1/2. 0.25. Therefore, going back to this, the probability of winning at least, that's going to be equal to 1 minus 0.25. 0.75.
0.005 is 1/2 times 1/2.
Yep.
Why did you do 1/2 twice?
Because we're playing 2 games.
Okay.
Okay, and I think what we're okay. Go ahead. Sorry.
Anytime it says at least once, it's 1 minus none.
Yes.
Okay.
Yes.
Okay. So then if it's none, is it 1 minus at least 1? But they're never gonna ask us for none?
Yeah. I did type it out.
Okay.
It's in the notes. Yes.
So why would you just for number 5? Since it says you do it twice, why wouldn't you just do it like double it, like how we did for like the number 4? Couldn't you have done that too?
Because we're playing 2 games in number 5. In question 4, you're only playing 1 game.
Oh, okay.
Or
For the and, if there's 2 circles in the Venn diagram, would it be just the middle part?
yes. Any other? Yeah.
Just, I want to make sure. So I know it's 4 decimal points, but do you round or do you not round? Do you round?
Round.
You round them up.
Yeah. Stats is a rounding class. Did you have a question, Paloma? Yeah. Okay. No. Okay. Any other questions? Because we're gonna turn you over to pizza right now. Okay. Yeah.
And for or, is the middle of it filled out also?
In or it's either the left half moon, the almond in the middle, or the right half moon. Okay, let's get some pizza.
Wait, can you
Not yet.